In 1952, the Boeing company took an enormous risk in developing a prototype jet transport aircraft. They gambled more than the company's net worth on the project. If the new aircraft had failed, it may have taken the company with it. In fact, the 707 family became one of the most spectacular success stories in the history of aerial transport. On the 15th of May 1954, the Boeing 367-80, now famous as the Dash 80, was rolled out before an admiring audience of employees and guests. Interest in the project was high, in spite of the traumatic experiences the British had encountered with the jet-powered de Havilland Comet. None of those assembled had any doubt about the significance of the occasion, but few guessed they were in the presence of one of the most important individual aircraft ever built. The Dash 80 was designed as a one-off, to prove the concept of a jet-powered transport. Drawing on their experience in jet bombers, Boeing's design team developed a totally new plane. The wing was an all-new design, with the same 35-degree sweep as the military jets, but much more rigid. Wing flaps were divided to avoid engine exhaust interference. Two sets of ailerons were used, one for high-speed cruise and the other for takeoff and landing. Dash 80 had a tricycle undercarriage with two sets of main wheels retracting into the body and a double nose wheel. It was powered by four Pratt & Whitney JT3 turbojets, mounted on single pods slung below and ahead of the wing. These were the civil equivalent of B-52 engines. Mounting the engines individually not only gave better weight distribution, but simplified the maintenance process. The hinged side panels of the nacelles allowed easy access to the entire engine. Taxiing trials began almost immediately, but on the 22nd of May, Dash 80 had a problem. Its port undercarriage collapsed. Although structural damage was slight, the test program was put back by 6 weeks for repairs. Dash 80 was 127 feet in length, with a wingspan of almost 130 feet. The cockpit accommodated a pilot, co-pilot, and navigator. There was no standard passenger seating in the cabin. As a purpose-built experimental aircraft, it had very few refinements. The fuselage interior was virtually bare and featured few cabin windows. Boeing had put 2 years of secret development into the plane and had very clear ideas what they wanted from it. Tex Johnson, Boeing's senior test pilot, was chosen to pilot the Dash 80 on its delayed maiden flight on the 15th of July, 1954. As the crew ran through their checklists, they carried with them the hopes of the company. Theoretically, there should have been huge military and civil markets for the plane. However, Boeing had been cautious. They had been in no hurry to enter the commercial market. This was partly because there was some resistance to jet airliners from the travelling public and the airlines. Also, the company was busy developing and building bombers. With Dash 80, not only did Boeing finally commit themselves to the market, but they stole a march on their opposition. the company's board had taken the decision to build the plane on the 22nd of April 1952. They were convinced the USAF would need to buy jet transports. They were also convinced that a suitable design would not only meet the military need, but could also be offered in a civil version. The 4 turbojets propelled Dash 80 into the air after using only 2,100 feet of runway. Johnson later noted that the plane wanted to climb like a rocket, and he had to throttle back to keep within the airspeed limits set for the first flight. The first uneventful test lasted only 1 hour 24 minutes, and in the 8 days following, a total of 15 hours 46 minutes flying time was logged. The increasing performance of jet fighters and jet bombers meant that these aircraft were forced to slow down and lose altitude when refueling from traditional piston engine transports. It did not take long for the USAF to evaluate Dash 80 and appreciate its potential as a tanker. Air-to-air refueling had become very important, particularly with the growth of the jet fighter fleet during the Korean War, and the available tankers were clearly inadequate. An all-jet tanker was needed. Dash 80 was the right plane at the right time. Three weeks after Dash 80's first test flight, and before it had been tested as a tanker, Boeing received a contract from the USAF for the delivery of 29 aircraft. It was a welcome boost to the company's morale at a time when there'd been little positive response to a civil variant. Dash 80 was soon fitted with a modified flying boom, and a successful refueling test program was quickly underway. On October 5, 1954, the military variant was officially given the designation KC-135A when the contracts were formalized. Although the initial military order was for a limited number of planes, the potential was enormous. Towards the end of 1953, the USAF had called for expressions of interest to supply the Strategic Air Command with a jet tanker fleet to extend the capabilities of its B-47s and B-52s. 6 companies had been invited to make formal submissions. The USAF tender actually called for the provision of 800 tankers. The stakes for Boeing were enormous. While Dash 80 continued its tests, production of the KC-135A began at Boeing's Renton factory. Although it could not be foreseen at the time, the model would continue to roll off the line for the next 10 years. No less than 732 KC-135As would be built. The A models were all fitted with uprated Pratt & Whitney J57 turbojets. They had considerable fuel capacity with up to 21 tanks. The KC-135A could carry up to 160 troops or 83,000 pounds of payload. Because polar areas are strategically important, a specially equipped version for operation in Arctic conditions was built. The aircraft had facilities to allow crew to live aboard for weeks at a time, independent of ground support. The equipment included a living area, bunks, and food storage facilities. The first production KC-135A Stratotanker was rolled out at Renton on the 18th of July, 1956. The basic KC-135A was little changed from the Dash 80 prototype, retaining the same overall dimensions. The first tanker flew on the 31st of August, 1956. After an initial test period, the type entered service with Strategic Air Command in mid-1957. The Stratotanker was distinguished by the absence of windows and the boom operator's station. The high-speed boom was slung neatly beneath the rear fuselage. As a military aircraft, the KC-135 was designed to performance and safety standards different from those required by civil authorities. The J-57 turbojets were water-injected and resulted in excruciating noise and sooty smoke on takeoff. With a gross takeoff weight of 316,000 pounds, the jet needed a field length of 13,600 feet, a distance unacceptable for civil operation. The airframe was built from a different alloy to the commercial variant. The flying boom refueling system adopted in the KC-135A was a Boeing invention. The 27-foot boom is constructed of concentric tubes and can be extended to 46 feet. Docking is controlled from the tanker by the boom operator, who flies the boom into position. After the boom makes contact with the receiver aircraft, fuel is pumped from the tanks through a series of valves and a pressure regulator into the boom, then into the receiver. The standard speed booms can be interchanged with high-speed booms to suit aircraft such as the SR-71 Blackbird. The Air Force contract gave Boeing both the confidence and financial security it needed to continue its sales drive into the lucrative civil market. Pan American was Boeing's first 707 customer, with an order for 20 aircraft in October 1955. To Boeing's irritation, Pan Am also ordered 20 Douglas DC-8s on the same day, even though that plane would not fly for another 3 years. The inaugural 707 airline service was launched on the 26th of October 1958, when Pan Am flew 111 passengers from New York to Paris. Soon after, American Airlines initiated the first scheduled passenger jet flight from Los Angeles to New York. Flight time across the US was effectively halved to about 4 hours. During the first 18 days operating the service, American carried 3,720 passengers, a load factor of 99.5%. Using doors at both ends of the cabin meant that passengers were able to board and disembark quickly. This was considered a major advantage, but it meant changes to airport design and operation. The first 707s were designated 707-120. The 120 had been designed primarily for domestic routes, although Pan Am adopted it for transatlantic flights. The cabin accommodated 121 first-class passengers or 179 economy. With the advent of longer-range 707s, most of the 120 series were relegated to domestic services. The 707's roomy fuselage and superior performance quickly became popular with passengers and crew alike. There were obvious advantages in flying above weather conditions that the contemporary propliners would have to fly through. Flights were smoother, faster, and much safer. The cabin provided space for twice the number of passengers of the older Constellations. Flying became a real option for more and more travelers. Just as jet travel killed off competition from propliners, it also sounded the death knell for most of the passenger ships, which even until the 60s carried more travelers than holidaymakers. To say that a revolution in transport had begun is an understatement. Competition from the Douglas DC-8, the Convair 880, and some of the European types would become intense. Boeing was forced to embark on a program of building even better jetliners. The original risk of $15 million had been left far behind. Now, the stakes would approach $100 million. Although Boeing held a considerable production lead with the 707, Douglas had attracted interest in the DC-8 by promising higher payloads, longer range and more powerful engines, as well as other advantages for both airlines and passengers. While Pan Am and American were plying their trade with the 707-120, another important version was already in development. In response to Douglas's challenge, Boeing had announced the development of a new 707 offering greater range and capacity, the Intercontinental 707-320. In a hydrostatic test tank, the fuselage of the Intercontinental 707-320 was subjected to the equivalent of 40 years flying, or 50,000 flight cycles. While submerged in the tank, the fuselage was intentionally ripped open, then stressed with cycles of abnormally high pressures and heavy loads. The torn body withstood the punishment without further structural damage occurring. The 707-320 first flew on the 11th of January 1959. So successful was the test series that only 35 days later the plane was handed over to the Federal Aviation Agency for certification trials. At Edwards Air Force Base in California, the Intercontinental was put through its paces. It could not carry a passenger until it received a certificate of airworthiness from the FAA. FAA test pilots undertook a detailed review of the aircraft's flying personality, while ground-based engineers measured the reactions of every component. Day after day, the test team propelled the mighty jet at altitudes from sagebrush level to stratosphere, over speeds ranging from near stall to 700 miles an hour. The Intercontinental 707-320 was over 12 feet longer than the 707-120 and had a wingspan almost 12 feet greater. It was the first of the breed to be truly intercontinental and directly challenged Douglas's promises for the DC-8. The powerful Pratt & Whitney JT4 turbojets enabled the aircraft to carry a payload equivalent to 189 passengers. One of the final tests in the FAA program involved ballast tanks being installed in the cabin and filled with water to approximate the weight of 180 passengers, or 45,000 pounds of payload. Another 9 tons were added for good measure, taking the aircraft's total weight to 316,000 pounds, a daunting prospect for the FAA team of pilots, engineers and technicians. As the test day dawned, conditions were perfect for maximum weight takeoff, and the big turbojets needed only 2/3 of the runway to lift the Intercontinental into the air. The 707-320 was offered with the Rolls-Royce Conway Mark 508 turbojet as an engine option. BOAC were one of the first to take this engine choice, mainly because the Conway was a British product and the decision to purchase the 707 rather than a British aircraft was politically sensitive. During the course of trials for its British certificate, a number of extensive modifications had to be implemented. These included a taller fin and power-assisted rudder, which were later included as standard on the production line. The first truly intercontinental flight of the jet age was the final test flight under full airline operating conditions. The Intercontinental 707-320, with its new Boeing livery, was bound for Rome, Italy. William Allen, the chairman of Boeing, had good reason to smile. After taking off from Boeing Field in Seattle, the 707-320 headed northeast on the Great Circle course. It overflew Canada, Greenland, Scotland and Germany. For most of the journey, the aircraft cruised at Mach 0.78, reaching a maximum altitude of 39,160 feet. It landed in Rome only 11 hours 6 minutes after takeoff. The journey was the longest ever undertaken by a jet airliner to that time. The next day, the plane flew on to Paris, Frankfurt and Brussels before landing at Heathrow for a night stop. The FAA certification was awarded on September 23, 1958, and the transport revolution continued. By the end of 1958, the Boeing plant workers at Renton were building for the airlines of 11 nations. As well as versions of the standard 707, they were also gearing up for the Intercontinental and a speedy new development. This variant would eventually be different enough to warrant its own identity. It would be marketed as the Boeing 720. Different variants were assembled side by side. The airline labels provide clues. South African Airlines had orders for the Intercontinental 320, as did Varig of Brazil. At the same time, this plane for Lufthansa is fitted with the Rolls-Royce Conway engines. This version had proved popular, and Boeing were now marketing it as the 707-420. As deliveries gathered pace, 707 milestones came in quick succession. The 100th 707, which rolled off the line in the livery of Air India International, was another 707-420. By the end of 1959, the medium-range 720s were rolling for United Airlines. In all, 154 of this model were constructed in 2 versions. Lufthansa flew home to Germany in record time. Sabena commenced 707 services to Africa and Russia. This model 720 was clocked at a speed of Mach 0.9, just as the designers had promised. A Rolls-Royce powered Intercontinental made history for BOAC with the first non-stop crossing of the North Pacific from Seattle to Tokyo. Air France brought the Model 320 into the transatlantic route. A special tropical version began service with Braniff. The new jets were so popular that until sufficient numbers had entered service, they were filled with first-class travellers. Within a year of entering service, over 2 million passengers had been carried. Australia's airline, Qantas, opened a service from Sydney to San Francisco. This was only one of many new routes opened up by airlines around the world with the arrival of Boeing's new aircraft. Despite considerable pressure to buy British, Qantas chose the 707-120. Boeing had designed this short-bodied version specifically to allow Qantas to operate from Sydney's short runway, as well as the short runways of its Pacific stopover destinations. The longer routes typically flown by Qantas meant that some passenger capacity could be sacrificed in favour of performance. The reduced capacity was more than repaid in the plane's improved range and speed. Only 7 were built, but they were a great success. Qantas passengers were to see the Pacific Ocean journey cut down to a mere 15 hours. Production of the last 707 series ended in 1979, after 917 of all versions had been built. 19 different models had been operated by 62 different airlines. At least 300 of those aircraft are still in service. One of the clearest signals that the jet age was here to stay occurred in December 1959, when this United States Air Force 707, a C-137A, landed in Rome. The jet, with President Eisenhower aboard, was on a mission titled Operation Monsoon. The President was to visit 11 countries in 19 days. Such a journey would previously have taken over a month. In Turkey, the President was greeted by over 400,000 people. In India, one of Eisenhower's dreams was realized when he visited the Taj Mahal with President Nehru. When he arrived in Athens via Tehran, he had covered the entire empire of Alexander the Great in one day's travel. The president's journey would take him through France, Spain and Morocco before his return to the United States. His trip was a triumph. Huge crowds greeted him wherever he went. But the significance of the journey went far beyond diplomacy. For millions of people, it opened up a new way of traveling the world. Package tourists have been repeating Eisenhower's experience ever since. For Boeing, the significance of the entire mission was that it was only possible because of the 707. Although the military had its own version of the plane, the C-135, the USAF had also purchased civilian 707 examples, distinguishing them with the designation C-137. They replaced the Air Force's small VIP fleet. From Eisenhower to Reagan, they carried each president in turn.
Folks, thank you very much indeed for coming out on this cold night to welcome my party and me back home. It's certainly good to be here. Now, I must remind you that this morning we had breakfast in Madrid, lunch in Casablanca, and now we are home at an hour which, by our getting up time, was 5 or 6 o'clock in the morning. So you can realize that this is not a time for a very erudite and informing speech.
As presidential transports, the planes themselves have become part of history. This aircraft, for example, was Air Force One from 1962 to 1972. Its saddest moment came when it was used to return the body of John F. Kennedy to Washington after his assassination. The name Air Force One has passed on to other airframes. It's actually the radio call sign used only when the president is aboard the plane. The VC-137s were operated by the Air Transport Wing. Each was configured with a custom-built interior, luxuriously equipped with only 22 seats. They were also fitted with very special navigation and communication installations for global self-sufficiency. In 1989, the presidential duties were taken over by a pair of Boeing 747s. In contrast to the small number of C-137s, a large fleet of their close relative, the C-135, was built. Many of the individual airframes have been repeatedly re-equipped, and they've been used in a mind-boggling array of configurations by many branches of the services. During the Vietnam War, the 135 series really came into its own, with as many as 10 different variants operating in the theater at any one time. Several of the series were modified to accommodate electronic communications and intelligence equipment under the direction of the Strategic Air Command. EC-135s, acting as airborne command posts, performed one of the most critical functions of the air war. They were developed from planes intended for a different purpose.
The EC-135 aircraft looks like just about any other C-135 series aircraft in the Air Force inventory. The big difference is in the back. This is the SAC airborne command post known as the Looking Glass. The airborne command post is a scaled-down version of SAC's primary underground command post and has the same basic capabilities. On a day-to-day basis, the underground command post controls SAC's forces around the world, but it would be a primary target for a potential enemy during wartime. If the underground command post is disabled, control of SAC's forces passes to the airborne command post. Its battle staff is trained to manage any counterattack the President may direct and to direct the recovery of returning bomber and tanker forces. There's an airborne command post flying over the Midwest 24 hours a day. Additionally, the Looking Glass aircraft has the capability to launch the Minuteman missile force if primary launch control centers are disabled.
At least 40 aircraft have, at some time or other, been modified to EC-135 standards. They've been fitted with a variety of equipment for use in several roles. The looking-glass planes are perhaps the most important.
3-4, Kim, turn it.
Yeah, we're about ready to take off.
Communications is the key element in maintaining command and control of the forces. Looking Glass is equipped with radios covering a wide spectrum of frequencies and includes the Air Force satellite communications system. At the touch of a button, the battle staff can talk to any SAC base around the globe.
The Looking Glass EC-135 was manned by a team of 16. This was made up of 5 flight crew, 10 staff, and a very senior officer.
Attention, battle staff. Major General Buckman is on board the aircraft.
The planes could be kept aloft indefinitely, being capable of reverse refueling from SAC bombers through the boom, as well as being equipped with a normal refueling point. Air Force EC-135s have appeared in 8 different versions. As befits their importance, they're given very special treatment.
Battery switch. Emergency. Check with ground. Ground pilot, clear on 3.
Time, sir. Clear 4.5, number 3. Fire gun position.
Turning 3.
Rotation.
Lights out.
Well, there's certainly been a lot of changes in the Looking Glass as far as the equipment and the performance of the aircraft over the past 21 years. But the basic mission to provide a survival command and control element has not changed. I think the great achievement is that it's been airborne continuously for 21 years, and that's due to a lot of dedicated people. We have outstanding air crews, battle staff, but mainly the people who support it on the ground have allowed this to happen. Primarily the maintenance people. They have to be out here 24 hours a day to ensure that we maintain this record and we can meet our commitment.
The EC-135s were first produced in the mid-1960s, but many of them remain in service today. Among their many service milestones are the tactical command during a 1986 raid on Libya, the confirmation of the Chernobyl accident through intercepts of Russian communications, and more recently, their key role during the Gulf War. In the late 60s, the USAF awarded Boeing a contract for conversion of 2 Series 320 civil airliners. On completion, there was no mistaking the pair, since both carried a 30-foot diameter rotating antenna above the rear fuselage. Designated EC-137, these were the first of the 707-based AWACS, Airborne Warning and Control System aircraft. The AWACS were developed as a combination of radar station, communication center, and command post. They're mobile, flexible, survivable, and jamming resistant. With the ability to offer long-range surveillance in all weather and above all terrain types, they've become an essential element of Western defense. As AWACS, the aerial sentries, the military 707s have really come into their own. A supersonic jet traveling at twice the speed of sound will move only 1/8 of an inch in the time it takes a laser beam to travel 1 mile. At the Air Force Weapons Laboratory at Kirkland, New Mexico, an airborne laser laboratory has been developed. The aircraft was rebuilt from an early KC-135 production tanker. It features a narrow hump on top of the fuselage with a rotating turret at the front. The fixture is 5 feet high and weighs around 4,000 pounds. The turret is capable of rotating at about 100 degrees per second. The Airborne Laser Laboratory is operated and flown by the 49th and 50th Test Wing. The carbon dioxide laser technology has been tested on all types of materials used in aircraft construction to determine effectiveness. The engineers and scientists on board are those who developed the sophisticated high-energy laser program. The airborne laboratory gives the scientists the opportunity to operate the equipment which they helped conceive, design and build. In addition, they've provided another instance of the multitude of appearances that the 707 family has taken on over the years. Since the mid-60s, the USAF has been constantly maintaining and updating its KC-135 tanker fleet. A notable milestone for the tankers came with the fitting of fuel-efficient fan engines for greater thrust and instant start capability. The 30% increase in thrust of the engines is accompanied by fuel savings of 27%, 85% less noise, and 90% less emissions. More important, the new engines have prolonged the life expectancy of the aircraft. The electronic, hydraulic, and flight control systems of the re-engined planes have also been updated as part of the same program. Another of the many oddly bulging variants in the 135 series have been a number of reconnaissance aircraft with a distinctive thimble nose. A spacious bulb houses sensitive radar equipment. Many of these aircraft have also been equipped with camera ports and fuselage antennae. Their intelligence collection is constant and very important. Even stranger looking were the 8 EC-135Ns. Here the deformity of the nose is more exaggerated, as it housed a 7-foot diameter dish antenna. The planes were converted in 1967, and their role was vital in the Apollo projects. Flying in pairs, these aircraft operated during manned spaceflights to permit continuous voice communications between the astronauts and ground control. In addition, they assisted in tracking the spacecraft. But in spite of the many wild and wonderful variants, it's still the KC-135 tanker that forms the backbone of the 135 series. Since the beginning of the re-engineering program in 1980, the operational difference has been immense. The re-engined KC-135RE saves up to $400 million from the USAF budget annually in reduced fuel consumption alone. The increased fuel economy also gives the aircraft the ability to offload more fuel as it needs less for itself. As well as the re-engineering of the aircraft, 33 other major modifications have been made to improve strategic readiness. Less maintenance is required so that crews can get airborne faster. Around the world, 24 hours a day, 365 days a year, there are crews on alert to man the KC-135 tanker aircraft. KC-135s were used to fuel the attacking F-111 force at least 4 times en route to Libya for the 1986 raid on Tripoli, and another 2 times on the way back. Without them, the raid would not have been possible, since both Spain and France denied the United States overflight rights. Besides the tankers, an EC-135E acted as tactical command for the raid. The final act of the raid came when another C-135 provided photographic evidence to Washington. In the Gulf, during Operation Desert Storm, US and French KC-135s provided the main in-flight refueling capacity for all US planes and several types of Allied aircraft. The powerful new turbofan engines give the rebuilt aircraft a massive thrust increase. Under normal weight conditions, the higher thrust enables takeoff up to 2,500 feet before a similarly loaded earlier model would leave the ground. Maximum takeoff weight is increased to 322,500 pounds. With the miserly consumption of the fan engines, the planes are able to offload 65% more fuel at a 1,500-mile radius and an incredible 150% more at a 2,500-mile radius. At present, the average C-135 airframe has flown only a third of its expected 30,000-hour life. There seems no doubt that the jet will be still in service beyond the current plans for their retirement around the year 2020. In 1972, Dash 80 was retired. Donated to the National Air and Space Museum, it sat cocooned in the Arizona desert for 18 years due to lack of exhibition space. The plane had been not only present at the birth of modern jet transport, but had been one of aviation's ultimate guinea pigs. It had helped to develop new aircraft and test new engines. In 1990, Dash 80's long sleep was disturbed. The old plane was refurbished for its final flight. A restoration crew began the painstaking task of bringing the old veteran back into flying condition. Every rivet was checked and rechecked. The old Pratt & Whitney turbojet engines were checked and overhauled. Finally, Dash 80 was ready, refurbished for its final flight back to its birthplace in Seattle. There it would be restored to go on display in Boeing's Museum of Flight. Pilot Paul Bennett and co-pilot Jerry White were at the controls. Preparing the old plane for the flight had taken a hand-picked crew of 15 technicians and engineers, a total of 1,000 man-hours. The world's most tested aircraft took off on its last long flight under a crew who were mere children when she first took to the air in 1954. The tests conducted on her 2,000 flights formed a mini-history of the jet era. En route to Seattle, Dash 80 stopped at Moses Lake, Washington, to pick up a celebrated team of old friends and admirers to be part of the plane's triumphant return to Boeing Field. First down the gangway among a team of Dash 80 veterans was none other than Tex Johnson, a man who first piloted the plane over 35 years earlier. Only one task was left to bring the jet back to its original glory. Using a new environmentally friendly paint stripping method employing dry ice rather than toxic chemicals, the plane was prepared for painting. Fittingly, this was the first use of this method, the Dash 80's last formal involvement in a test series. Every attention was given to recreating the original distinctive livery, and finally the jet was ready for its public. It is fitting that a plane as historically important as Dash 80 should be preserved. The plane should never be forgotten, just as its contribution to aviation should never be underestimated. The Smithsonian has declared it one of the 12 most important aircraft of all time. Before its retirement, the plane was given one last flight to show off the gleaming new paint job. When Boeing started work on what was to become the 707, they were a very minor player in civil aviation. Today, they're the dominant force. The market itself has changed because of the fateful decision taken by the company board in 1952. The arrival of the 707 opened up air transport to a new mass market. The many successful and important military aircraft based on the design are ultimately less significant than the civil development. When the Dash 80 took to the air for the first time, the world became a smaller place for all of mankind. Though well past its prime, the 707 continues to ply its trade in the skies. It will do so well into the next century, being updated and maintained as freighters and specialist aircraft for as long as life remains in its aging but solid body.